Good afternoon, everybody. So my name's Josh Bailey, Technical Director at Gateway Electronic Components. I'm here to talk today about our Ferrite machine shop. So we specialize in machining custom Ferrites from blocks. And that's part of Gateway Electronic Components. So some background on what we do. So we are one of the largest distributors of Ferrite materials within UK and Europe, but we are the only distributor of Ferrite to have an in-house machine shop that's dedicated to machining Ferrite. And that puts us in a very unique position, especially in new designs. We're seeing a lot in EV, charging, rotary transformers, where we essentially remove the cost of the historic pressing tool. And we remove that to make your project and your time to market much cheaper and much quicker than it ever used to be. So why machine Ferrite cores? So historically, if you needed a custom Ferrite, you would start with some of the big factories in Europe, the likes of Ferrite, TDK. You would go through the design phase and you would have a pressing and sintering tool, and you're talking 15,000 euros before you can even manufacture a part. And so by machining cores, we're able to take blocks from the factories and machine those to your custom geometries without any tooling costs. The other side, you have the leading factories. I mean, Ferrite is probably the leader in materials at the minute, constantly evolving their selection. Every year there is a new material from Ferrite. But the problem is, when they release materials, TDK are the same, they will release this new wonderful material, but you can't actually get that material in the core that you want. And so you can't then analyze the performance of that material in your application. What we can do is actually, we remove that hurdle. So we can gain blocks in all of these materials and machine that for you. So you can then benefit from testing the newer materials, but without this uplift of tooling. The other side of it is, ultimately, we machine to extremely tight tolerances. So high performance applications like Formula One, aerospace, some of the tolerances they require can be plus or minus 50 microns, 10 microns, and we're able to achieve that. If you're talking about historic pressing and sintering of a product, your tolerances can be plus or minus 1 mil, 1.5 mil, depends on the size of the core. And so there's a historic misconception. So both of these have actually been taken from LinkedIn. I'm an avid fan of LinkedIn. I think there's a lot of great material on there, but there's also things like this, where if you went back 10 years, these statements were true. So what we're talking about here is custom cores instantly mean that they're expensive, there's a high MOQ, and the lead time is 20 weeks. So people tended to move away from that and try and standardize around mass-produced cores. And that really comes from manufacturing in Ferrite in the past. It was all done at the factories. So you start with, here's my design. I want to test that in application. You'll then return with a quote from the factory to say, look, tooling cost, 15,000 euros. Here's your MOQ, 20,000 pieces. And you've instantly got this huge jump where you've got to make sure your design is absolutely perfect. You've got to know that your material is going to perform how you expect. And that creates quite a risk. And what we're there to do is reduce that risk. Distribution networks have existed for years, which is where Gateway Electronics fits into this. But we've taken it a step further, and the machine shop acts as the middleman between using a distributor and using a factory, but we have the direct links to the factory to be able to get you that quick response. So where we are now with the machine shop, your MOQ can be one piece, it can be 10,000 pieces, but you could order one piece from us and we'll deliver it in 1 week, and at a cost, our minimum order value is €250. So we've removed all of these historic issues. So factories on one side, obviously you could deal direct with these guys. You'd have to be a certain scale of company for them to talk to you. But the problem here is in each factory you have a contact. You also have their range of materials, and so if you want to evaluate your core in, let's say, Ferrite 3C96 and TDK's N87, you would have to talk to TDK direct, discuss with contact there on the material range. You'd have to then do the same with Ferrite Cube, and you've already got two lines of communication open. So distributors can sit there in the middle of this and really manage that, but the problem with the distributors is they are still reliant on the factories. So they still sit in the middle, and really there's no way for them to progress because they have no control over manufacturing or the technical aspect. So the solution is our machine shop. And we sit in the middle and we talk directly to the factories. So we're obviously doing the machining, we're advising on design, but when we advise on design, we make sure that we don't design in something that can't be pressed on mass production in the factory. So if we see a design with a certain feature in that you can't physically press, then we'll advise you on that. And we're shortening that design period. But you're dealing with us direct, and we have access to the full range of materials in-house. And so we can give you all of the advice. That it's all about reducing that time to market from you creating your design to getting this thing in your hand can be as short as 1 week. And that's what I really summarize here. We represent TDK Epcos, Ferrite Cube, Magnetics Inc., and Chemit. And so we stock blocks from all of these in our facility in the UK. One point of contact. We have a broad range of materials that cover all applications, so power, signal, wireless power transfer, and everything in between. We make sure that the materials you're specifying have a lifetime on them, so you're not designing in materials that the factories are actually trying to phase out. You can actually order the same part from us in 2 different materials. So if you're not sure, theoretically, you might look at N87 and 3C90 and say, well, they're going to perform the same. That might not actually be true in your application. So you could say to us, please deliver me this product in N87 and one in 3C90. We work with you on the design. We don't just look at, is this scalable in terms of volume? We also advise on if you've designed certain features that are actually perhaps increase your price by 50%, we'll tell you that to try and help you balance, perfect core for the application versus you might have a budget to hit and a target price that with the features you've designed in isn't achievable. So we help manage that with you. Lead times, we can turn things around in 1 to 2 weeks. The quickest we've ever turned anything around is actually in 1 day, so it can all be done. If you then need to do a design revision, there's no tooling involved in that. You just place another order again for the same part, and we can rework that for you, make the modifications again in a 1 week lead time. As part of that process, we'll also not only quote you for machining the part, we look at the projected long-term volume of the production, and we can quote direct from the factory the prices for this to be pressed and sintered, and then we also perform an analysis, which I'll come to. So our capabilities, there's a motto that we follow, which is if you can dream it, we can machine it, and I'm yet to turn anybody away. So if you can send me a drawing, I would say we can machine that for you. So it's everything you would expect from standard center limb gapping all the way through to completely custom 3D profiled machine cores. So in-house, 3-axis, 5-axis CNC machines, surface grinders. We have some of the latest cutting-edge Renishaw laser probes, which help us keep our tolerances down. So tolerances on inductance values to plus or minus 1%, dimensional values down to plus or minus 5 microns, and our general machining tolerances, like day-to-day 3D profiles, plus or minus 50 microns. And we do that because we use the latest cutting-edge technology. So this is an example of a project that we were working on this year. And the customer came to us and said, I have a custom part, military application, and they'd already done the design. They needed to evaluate it first, but they wanted to understand lead times, the projections for the volume manufacturing. And what we do as part of the process is we work on the design. So it was an EP core, which had a slightly strange offset, actually. So we machined that for them for 30 pieces. Total cost to the customer was €670. If you went back 10 years, the customer would actually end up having to pay €13,000 to evaluate that core. And by using the machine shop, you've dropped that down to €600. But what we also do is we look at the total cost and say, okay, well, year one's projections was around 20,000 pieces, all the way up to the 120,000. So we gained the quote from the factory, and that sat at €13,200. So I think around 10,000 of that 13,000 was actually the pressing tool that's needed. And so we look at that and work back from there and say, how many can we machine for the same total cost of ownership? And we have a cut-off around 2,000 pieces, and we give this to the customer to let them make the decision on at what point do you want to transition to the pressing and moulding tool, but you can also manage the short-term risk as well, because our lead times are set at weeks, and to get to this point, you're going to be waiting at least 12 weeks to get your tool made. So whilst your tool's being made, you can actually already have your production running, because we have no tooling involved. So I have one more example. This is actually an antenna, and the distance between there and there is 5 millimeters. And if you want to see this in real life, come onto our stand. These things are very, very small. And this customer was actually a design house, and they actually had 5 designs or design variations on this core that they wanted to evaluate. And they were able to evaluate all of these using a one-off cost of €30 each. And what that allowed them to do is then take the 5 designs and create the perfect design that balanced. What they found on some of the designs is actually the center limb was too thin, so they couldn't actually wind it. As soon as they started to wind it, the core fractured and broke. So through that iterative process, the customer was able to establish the perfect geometry, but also balance the magnetic performance of the core. They also tried this in 2 different materials as well. And so they ended up refining down to the perfect scenario. And they did that for the total cost of ownership of less than €200. And you'll see when you start hitting the large volumes, the factory actually set an MOQ of 50,000 pieces on this because it had to be injection molded. So it wasn't a pressed and sintered core, and as soon as you move to that technology, the MOQ suddenly jumps to 50,000 pieces. So we actually sit in the middle all the way up to what we would call a medium production run of 10,000, 20,000 pieces. And then beyond that, they moved over to the molded version of that core. Our biggest benefit is the blocks we stock. So all Ferrite blocks that we stock are made by the leading manufacturers within Europe. So TDK, Ferrite, Chemet, and Mag Inc. We also stock Mag Inc.'s powder cores, and that is actually really quite a unique scenario that we have. I don't know anybody else that stocks these and can machine them. You'll see our extensive list of materials from Ferrite Q. You'll probably see some in here like 4PDP, 4PD4. These were actually made specifically for one customer's application. So they needed a super flat temperature curve at a very particular temperature. None of the materials actually kind of met that application, and so we worked with Ferrite Cube to develop this new material. And again, because this is new material, so it's not a mass-produced part, we had to then machine the block to the part that was required. But all of these sit in stock, which is how we're able to turn around custom geometries within 1 week. So just to summarize, if you want to see more of what we do, we have a stand in Hall 7. On stand 1 to 8, we have a vast array of samples, some of them that you see here. The tiny little core we were talking about before was there. We have them on the stand as well. So please come and talk to us. And if you have any questions, I'd be happy to answer them. Thank you.